In the circuit shown here, the point C is kept connected to point A till the current flowing through the circuit becomes constant. Afterward, suddenly, point C is disconnected from point A and connected to point B at time t equal to 0. Ratio of the voltage across resistance and inductor at time t equal to L by R will be equal to. Clearly, it is a case of an LR circuit. Initially, point C is connected to point A. So, when point C is connected to point A, it becomes an LR charging circuit. During this condition, what happens is, as the current starts flowing from the battery to the resistor and to the inductor, inductor starts opposing the growth of current in a circuit by developing an induced EMF which opposes that current. So this is how the circuit will behave. After some time, the current will become steady. The most important and noteworthy point of this entire initial part of the circuit is that initially the inductor gets charged, and after the saturation current or steady current is obtained, it is known as active inductor. This active inductor is one which retains the memory of current. Suppose this current over here in the circuit is I0. So this inductor will retain the memory of this active inductor even if it is disconnected from the circuit and reconnected again to the circuit. So now when this inductor, that means the circuit, is bypassed from the battery part, now it is given that the switch C or the point C is connected to point B. So when this happens, point B connected to point C, as discussed earlier in this part, the inductor retains the memory of the current and current still flows in the same direction in the circuit. Now the question is related to the voltage. It is not related to current. Now this circuit becomes LR discharging circuit because the energy of the inductor will be discharged through the resistor. So during this part, the energy would be shared by resistor and inductor through the various values of current. But here current is not at all required, it is voltage required. So if we apply Kirchhoff rule to the circuit, let us start from point C. So we can write minus VR minus VL is equal to 0. This is from Kirchhoff voltage law. So that gives VR is equal to minus VL. It is required to find out ratio of voltage across resistance and inductor. So VR by VL is equal to minus 1. So in this case, we can see option B is satisfying the given condition.